Hello. We're going to go do the next video for the next in the spotlight. This one is called Converting a Math Formula to a Programming Statement. Let me pull this over and we'll go through it. Suppose you want to deposit a certain amount of money, excuse me, into a savings account and leave it alone to draw interest for the next 10 years. At the end of 10 years, you would like to have $10,000 in the account. How much do you need to deposit today to make that happen? You can use the following formula to find out. P equals F over the quantity 1 plus R to the nth power. So the terms in the formula are as follows. P is the present value, or the amount that you need to deposit today. F is the future value that you want in the account. In this case, F is 10,000. R is the annual interest rate. N is the number of years that you plan to let the money sit in the account. It would be convenient to write a computer program to perform the calculation because then we can experiment with different values for the variables. Here's an algorithm that we can use. We get the desired future value, we get the annual interest rate, and we get the number of years that the money will sit in the account. Calculate the amount that will have to be deposited, and then display the result of the calculation in step 4. In steps 1 through 3, we will prompt the user to enter the specified values. We will assign a desired future value to the variable named future value, the annual interest rate to the variable named rate, and the number of years to a variable named years. In step 4, we calculate the present value, which is the amount of money that we will have to deposit. We will convert the formula previously shown to the following statement. The statement stores the result of the calculation in the present value variable. So present value equals future value divided by the quantity 1.0 plus rate taken to years power. That's what the two asterisks are, to take it to the years power. Step 5, we display the value in the present value variable. And so we're going to go ahead and write the code for this. And again, I'm going to start up Python. And open a new file. So the first thing we need to do is get our future value. That's going to be equal to a float input so enter the desired future value. We then want to get the rate. So rate is going to be equal to float input and then we need to get the years. Keep hitting the wrong keys there. Okay, so that gives us all our values. Then we need to calculate out the present value. Really help if I could hit the right keys. So present value is going to be equal to our future value divided by the quantity 1.0 plus rate taken to years power. Then we're going to print this out, and we're going to use, or just do the label. There we go. Okay, pretty short program on here. So one thing we need to be sure sure that we do, and it doesn't specify this stuff in the description, is rate has to be a percentage. So it has to be like 0.5 for 50%. Let's see, there was something else on here also. Oh, and then rate is also, oh, I got that messed up there. Let me fix that. This is plus in here. Rate also has to be the annual percentage rate. Okay, so that's normally what we talk about when we say like 12% or whatever. But some formulas need a monthly interest rate, so you would have to divide it by 12 in order to get the monthly one. But in this case, we want the yearly one, so this works out here. So, okay, I'm going to go ahead and get this saved. I'm going to save this as future value. And do capital on this. .py, and then specify where I want to save it. Go and save that in there, and then we'll test this out. Now I'm going to use the examples that it gives here so I can make sure I get the right values on here. So let me go ahead and run this. I'm going to use 10,000.0 as my future year for future value. I'm going to use for the interest rate 0.05, so that's 5%. And then I'm going to use as the number of years 10. And that's the answer that I get, 6,139.132, and so on. So eventually in the chapter we'll get to where you can start seeing how you can format these numbers and make it look a little bit better. But for right now, this is the way we did it here. We could run this again and put in some different values. Okay. So let's say we want to do 100,000. And the interest rate on this is going to be 8%, so 0.08. And we're going to put it in here for 15 years. Okay. So when we want $100,000 in 15 years, and we're going to get 8%. Okay. So to do that, we have to deposit 31,524. So then you, as the person, have to determine, is it worth tying up $31,000 in order to get $100,000 in 15 years. Okay. So just something to think about on that. Anyway, something else to think about is, and we can't do this yet. We'd be able to do this after chapter 4 or in the middle of chapter 4, is being able to run this through a loop so that they can put in multiple sets of values to get results for those instead of having to run it each time. Another one would be to check to make sure that the percentage or the annual interest rate was put in as a decimal rather than as a whole number. So for the example that we did, the 8%, if they put it in as an 8, it wouldn't run right. So in chapter 3, you learn about decision structures, and in there you can then check to see if our rate is greater than 1, or greater than or equal to, let's see how to do it. I'm sorry, it would be less than 1. If it was less than 1, then it would be okay. But if it's greater than or equal to 1, it means they put it in as a whole number rather than as a decimal. And so then we would have to convert it. Okay. So just some things to think about. Let me know if you have any questions, and we'll get going on the next video. Bye.